d2 plus d1 and d2 minus d1 d2 plus, so d2 minus d1 have taken common outside here, d2 minus d1, and again d2 plus d1 whole square, it will multiplication of that 2, and 4d1 d2 minus 1, that is the equation. So then HL is equal to energy loss is equal to d2 minus d1, this one a plus b whole square, d1 d2 square a square plus 2 into d1 d2 plus d1 square d1 square d1 square divided by 4 d1 d2 minus 1. So then energy loss is equal to d2 minus d1 and d2 square plus 2 d1 d2 plus d1 square divided by 4 d1 d2 4 d1 d2 minus 4 d1 d2 4 d1 d2, that is energy loss formula. So next I can write this equation, a plus b whole square, we know that one, this is a, and next I can write this equation d2 d2 minus d1, say power 1, and this one you can write a plus b whole square d2 minus d1 whole square divided by 4 d1 d2. So here what happens, this x into x square into x cube, so this final equation it becomes HL is equal to d2 minus d1, final equation it becomes d2 minus d1 whole cubed divided by 4 d1 d2. This is the energy loss due to hydraulic jam. This is the equation of energy loss due to hydraulic jam. Okay. Next we will go for that hydraulic jump due to Froude number. That is also we need to hydraulic jumps due to Froude number. That is also one important topic that also we need to discuss here. Hydraulic jump due to Froude number. Hydraulic jump due to Froude number. according to Froude number, how the hydraulic jumpers we need to calculate. According to Froude number, hydraulic jump we need to calculate. Hydraulic jump due to Froude number. So we are having that equation in the last previous derivation. If you find it, d2 is equal to, with respect, d2 is section 2 depth, and d1 divided by 2 plus root of d1 square by 4 plus 2v1 square d1 into g. This equation we are having in the previous derivation. If you can see, you can get it, that equation. And depth of hydraulic jump, we know that that's 2 section d2 minus d1. So again, according to the Froude number, hydraulic jumps we need to calculate. So here here what we need to make, d1 minus d1 by 2 2v we are having, and here plus d1 square by 4 is there. So I can write it d1 square 4 d1 square 4. Here I want the d1 square by 4 in both sides. So how can I bring it here? Plus 2v1 square, here multiply and divide by both side, multiply and divide by d1. So d1 into d1, it will becomes d1 square. No, I want d1 square by 4 divided by, multiply and divide by d1 into g. Again I want to d1 square by, it will becomes d1 square by 4. Again I will divide by and multiply by 4 here. So next multiply and divide, first I multiplied by d1 and divided by d1, and again multiplied by 4 and divided by 4. So next it will what happens, d1 square I will bring it common outside. So so how you can write this one, d2 is equal to minus d1 by 2 plus or minus this equation, d1 square by 4 we are having, and because both side is d1 square is there, so I bring it outside common d1 square 4. Then remaining is 1 plus 8 v1 square divided by gd1. So if d1 square by 4, if this one d1 square by 4, if you bring it outside, then it is becomes 8 v1 square by gd1. 8 v1 square. I have taken d1 square is outside, so remaining is d1 square by 4, inside the bracket 1 is d1 square by plus 8 v1 square by gd1, because here remaining is if it is this d1 square and by 4, it means remaining 1 2 4 into 8 v1 square by gd1. So then Froude number it's always occurs if when the flow is in gravity. So then we can write it, if it is having flow is flowing in gravity, so there is a Froude number, and because of the gravity, the Froude number will create. And when it is critical, the depth of the flow is below the critical height, then it is hydraulic jump will create, what we discussed. And we are having the Froude number formula, Fr is equal to v root of gd, f fr Froude number is equal to v root of gd. So for section 1 what happens for the section 1 fr1 Froude number 1 v1 root of gd1. So next, that is for section 1 and section 2 fr2 V1 square divided by root of GD1. GD1. So that is for section 2.2. So then how we can write when this equation? This equation how we can write it? 1/8 V1 square by GD. So this is for section 1.1. We can write it D2 is equal to D2 is equal to minus D1 by 2 plus or minus root of D1 square by 4 1 plus 8 V1 square by GD1. We know that value is Froude number 1. Froude number 1 square. Froude number 1 square. So this one we can write it Froude number 1 square. This one I can write it here D2 is equal to D2 is equal to D1 by 2 plus this one I'm bring D1 square by 4 D1 square by 4. When I'm bringing outside, it will becomes D1 by 2 and inside the root 1 plus 8 f Froude number 1 square. 1 plus 8 f Froude number 1 square. So I can write this one D2 is equal to this D1 by 2 and D1 by 2 that were commons. So I can write D1 by 2 1 plus 8 inside the bracket 1 plus 8 f R1 square minus 1. So I can write it this one. This is the final equation. We are for the base section 1.1. So if we are not clear, I can write it again this here this side. D2 is equal to D1 by 2 1 plus 8 f R1 square minus 1. This is depth of hydraulic jump due to Froude number. So this is the equation. So depth of hydraulic jump we can calculate. We know we discussed about that one. Depth of the hydraulic jumps. Section 1.1 and section 2.2, and this is D2 and this is D1. So D2 minus D1, this is we can get depth of the hydraulic jumps. So this is the one derivation for all hydraulic jumps for hydraulic jump due to Froude number and hydraulic jumps due to loss of energy due to hydraulic jumps.